Let's start the session. So in this particular session, we will be solving gate level questions. It is a gate practice crash course. We will be solving around 15 questions and they are all gate level questions. Okay, start करें. Hello, hi Vittal, how are you? चलो, before we start the session, let me make some few announcements. So as you already know, we have started our batches for GATE 2024 and 25 and 26. 25 batches are already started. So if you want to prepare for GATE 2025 or ESC 2025, you can call on this number and find out all the information about these batches. It is a very structured course. You will have live classes, recorded lectures in case you miss the classes, study material, practice quizzes, mock tests. So a very structured course we have designed for you. Everything from scratch till the advanced level will be covered for GATE and ESC. Okay, chalo. Also, if you are on the app, you will get all the information, what subject is going on, which batch is going to start. So in order for that, you can download the app. Okay, so to get all the information directly, you can download the app. Below this session, you will get this link. You can click on this link, directly download the app, and all the information is already put out there for you. You can get all the information about the upcoming batches, about the seminars, workshop that is going on for GATE 2024, GATE 2025. Chalo. If you have not joined my Telegram channel, do join the Telegram channel. It is very important because this is the only way you can connect with me. Mechanical by Vipin Yadav. You can scan this QR code or you can just search in the name Mechanical by Vipin Yadav and you can join. Chalo. Let's start the session just after a quick introduction. So as you guys know, hello, I have 6+ years of teaching experience. I have taught for GATE, ESC, JEE, PSUs, AE and all other state exams as well. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. 3.5 years of industry and research experience and few research publications as well. My area of expertise, as you all know already, it is basic and applied thermodynamics and heat transfer. ठीक है? Hello, good evening Maniket. चलो start करते हैं पहले क्वेश्चन से. Let's start with the very first question that you may have seen or not, I don't know. Let's start with the very first question. So a platinum wire is used as a resistance thermometer. The wire resistance यानी कि R is found to be 10 ohm and 16 ohm at ice point and steam point respectively. That means unlock free trials. Yaar, you can do this. You can call on this number. They will guide you because I am not very sure. But of course, even I saw some messages regarding, free trial 3 days or something. You can call on this number. This number you can call and they can guide you. Okay? ठीक है? They can guide you how to unlock this. Got it? Chalo. Now, so 10 ohm and 16 ohm at ice point, यानी कि when temperature is ice point means 0 degree Celsius and steam point means 100 degree Celsius, and 30 ohms at sulfur boiling point 144. It is 30 ohms when temperature is equals to 446.6 degrees Celsius. Resistance I need to find at 500 degrees Celsius. यानी कि find out resistance when temperature is equals to 500 degrees Celsius and the relationship between resistance and temperature is given. That relationship between resistance and temperature is given. चलो, so देखो, by resistance is equals to R naught 1 plus alpha T plus beta T square. I need to find resistance at temperature 500. The only issue is I don't know R naught, I don't know alpha, I do not know beta. So what do? I have to use these three boundary conditions. So first, if I use this one, so I can write 10 is equals to R naught 1 plus alpha into 0 plus beta 0 square. So from here I will get R naught is equals to 10. R naught is equals to 10. Yes, chalo. Now let me apply the second boundary condition. So I can write 16 is equals, now R naught is known. So I can write 10, 1 plus 100 alpha plus 100 square beta. Okay. Then I can write the third equation, which is 30 is equals to 10, 1 plus 444.6 alpha plus 446.6 square beta. So now you have to find out alpha and beta. Two equations, two unknown. Can you find out alpha and beta? Quickly give me alpha and beta. Alpha and beta. So alpha is how much? Alpha you are going to get, let me write it, I have to check. Okay, it is 6.43 into 10 to the power minus 3, and beta is equals to minus 4.35 into 10 to the power minus 6. Now you know everything. You can write R is equals to 10, 1 plus 6.43 into 10 to the power minus 3 into 500 plus, I can write directly minus here, minus 4.35 into 10 to the power minus 6, 500 square. So this will directly give you R. This will directly give you what they are asking. They are asking this. So R is around 31.275 ohm. Getting it? Getting it or not? Yes. चलें आगे, चलें, चलो, let's move ahead. Guys, you have to solve it before me, okay? चलो, very simple question. Pressure and volume of a gas undergoing an isothermal expansion process are related like this. So pressure and volume is related like this. A is given, B is given, R is given. Work done by 10 kg, यानी कि mass is also given 10 kg. Gas expanding from volume 1 is 1 meter cube, volume 2 is 10 meter cube at temperature 293 Kelvin. I need to find out. So what is work done? Work done is equals to PdV. Now it is, I have to integrate with respect to volume. So I have to determine this equation in terms of pressure. So I can write pressure is equals to mRT by V minus B minus A by V square. This I can write. Okay. So pressure is what? Let me write it C. Okay. C upon V minus V dV minus A dV by V square, where C is equals to MRT. M is 10, R is 0.278 and temperature is 293. So this you can determine how much is it. Tell me how much is it. Tell me how much is C. ठीक है चलो. Now if C is known, I can write C ln V minus B V1 to V2 minus A minus 1 by V V1 by V2 V1 by V2. So now you can substitute. C you can substitute here directly. Ln you can write what? 10. V2 is what? 10. V2 is what? 10. Minus B is 0.0107 minus ln कितना आएगा ये 1 minus 0.0107 plus A. 1 by V2 is 100. 10 minus 1 by 1. So A is also given. A is also given. C you have, see how much is C? 814. C is 814. So you can substitute C here. You can substitute A here, and you can find out work done is equals to how much you are getting. How much you are getting work done? Are you calculating it? Work done you are going to get. Work done you are going to get 1742. 1742.12 kilojoule. You will get this. ठीक है, चलें आगे चलें. Good questions are going to come now. Okay, slowly we'll move to better questions. 1742. ठीक है, चलो next move ahead. A spring-loaded piston cylinder device contains 5 kg of helium as a system. The system is heated from mass is equals to 5 kg. Okay. So P1 pressure is 100 kilopascal and T1 is equals to 20 degree means 293 Kelvin. 2 we are going to P2 800 kilopascal to T2 which is 160. 160 is how much? 433 I think. Yes. 433 Kelvin. Determine the heat and work interaction by the system. Heat and work interaction. So see, by spring loaded piston is there. That means the pressure and volume will be linearly related. Linearly. So I need to determine V1. V1 is equals to M R T1 by P1. So M is what? 5 kg. R is given 2.08. T1 is 293 by P1 is 100. कितना आ रहा है V1? Now calculate V2 as well. 5 into 2.08 into 433 by 800. How much is V2? V1 and V2. How much is V1 and V2? This is 30. 0.472 meter cube. And if I am correct, this you will be getting around 5. Let me check. Yes, 5.621 meter cube. So basically, I know P1, I know V1, I know P2, I know V2. So therefore, the relationship is linear. P1 is 100 and V1 is 30. Okay, this is V1, P1. P2 is 800 and 5, yani ki P2, V2. So you are going from this point to this point. This is your process. This is your process. So if they are asking calculate work output, so calculate work output means what? Area under this curve. Area under this curve. And how can I do that? Half P1 plus P2 and V2 minus V1. V2 minus V1. Now it will automatically give you negative because it is compression work. You can see volume is decreasing, pressure is increasing. ठीक है, चलो. So half 900 into 5.621 minus 30.47. So you can find out how much is work done. How much is work done? How much is work done? कितना आ रहा है work done? It is minus 11182 kilojoule. आ गया? So if it is minus means work input. It is work input. So work input is this. Work input is this. 22 क्यों आएगा भाई? 22 क्यों आएगा? देखो ना. 5.621 minus 30.47 into 900 by 2. डिवाइड नहीं किया 2 से. 2 से डिवाइड नहीं किया. Yes. Now heat output. How much is heat transfer? So you see, in this process, for any process, can I write for any process? dq is equals to du plus dw. Now I need to find out dq. And what is this? m cv T2 minus T1 minus 11182. Mass is 5. This is 3.12. T2 is 433 minus 293 minus 11182. Quickly find out how much is this. Quickly find out how much is this. dq. It will also be negative. It will also be negative something. कितना आएगा? 8998 kilojoule. So if it is negative, what does it mean? It is heat output. Heat output. Going out heat. Yes. एट 998 आएगा. क्लियर है? आगे चले. आगे चले. चलो नेक्स्ट क्वेश्चन. द पिस्टन ऑफ अ क्लोज सिलेंडर ऑफ I have a piston here, is retained in the position. Dia is what? 0.25. So piston area is what? Pi by 4 d square. Tell me what is area. Tell me what is area. it is retained in a position through spring and stoppers. So यहाँ पे it is put by spring and stoppers. Volume on one side of the piston contains air, यानी कि V1 is equals to whatever, V1 is not given, P1 is given. P1 is 750 kilopascal. And at this point of time, the spring mount exerts a force of 120. So right now the force exerted is 120 Newton on the initial position. When the stoppers are removed, now you remove the stoppers and piston moves here. If you remove the stoppers, piston moves here. So it travels 1.2 meters, 1.2 meters. The spring force is linearly increased with the piston displacement, and the final force is 5000 Newton. The work done by the compressed air. Now there are many ways I can calculate. There are many ways. I will give you two ways. First is directly work done is what? By joule. So it can be force into distance. Now force is what? Average force. So now earlier it was 120. Finally it is 5000 by 2. And distance traveled is 1.2. So this will also give you the work done. Tell me how much is work done? Work done is around कितना आएगा? I think 3072 joule. 3072 joule यानी कि न्यूटन मीटर. You can also calculate this. The second way that you can calculate is PDV. Pressure and basically change in volume. PDV. ठीक है, चलो. So देखो, you can find out initial pressure, final pressure. By initial forces P1 is equals to F1 by A. एरिया कितना आया ये? 0.785 into 0.05 meter square. So it is 120 by 0.05 something. You will get P1. P2 you will get final F2 by area. F2 means 5000 by 0.05. Okay, so that means you are going, let me draw it here. Let me draw where should I draw? Let's draw here. So what is your initial pressure? How much is this? 120 divided by 0.05. It is, let us say, 2.4 kilopascal. But you have to divide by 1000. Okay, it is 2400 basically. It is 5000 divided by 0.05. So it is 100 kilopascal. That means you are going from 2.4 kilopascal to 100 kilopascal. Sorry. You are going from, it is expanding. Expanding means volume is going to increase. Okay, it is going up, the volume is going to increase. So you are going from 2.4 kilopascal to 100 kilopascal, and the volume is how much? By volume is how much? Area of piston into dx. ठीक है, एरिया ऑफ पिस्टन इनटू dx, दिस विल द वॉल्यूम। भाई वॉल्यूम चेंज कितना हुआ है, इतना ही तो डिस्टेंस ट्रेवल किया है, तो दिस इज द वॉल्यूम, दिस इज द वॉल्यूम। सो नाउ यू कैन डायरेक्टली फाइंड आउट वर्क डन इज इक्वल्स टू हाफ P1 plus P2 into dV, and dV is what? This half, this is what? 102.4 into 0.05 into 1.2. 1.2. Calculate how much is it? 102.4 into 0.05 into 1.2 divide by 2. Same you are going to get 3.072 kilojoule. Same you are getting here 3.072 kilojoule. So anyway you can calculate, no problem. You can calculate any way possible. ठीक है, चलें आगे। चलो नेक्स्ट क्वेश्चन। In a oil cooler, air, oil flows. So I have a oil cooler, you see. So it's basically a heat exchanger. And oil is flowing here. This is oil. Red one is oil. Through a metal tube submerged in a stream of water. Blue is water. This is water. Now, what it is telling you? It is telling you the oil is entering T oil inlet is equals to 90 degrees Celsius. T oil exit is 30 degrees Celsius. Temperature water inlet is 25 degrees Celsius. Temperature water exit is 70 degrees Celsius. The enthalpy of oil at T degrees Celsius is given. So enthalpy of oil is 1.68 T plus 10.5 into 10 to the power minus 40 square kilojoule per kg. Mass flow rate of oil is 2.78 kg per second. Determine mass flow rate of water. I need to find out mass flow rate of water. I need to find out mass flow rate of water. So what will I do? Steady flow energy equation. Steady flow energy equation. Mass in H in plus Q in is equals to M exit H exit plus work of control volume. Now there is no heat transfer, no work transfer. When I say no heat transfer, that means between system and surrounding. Here it is taking place. Here it is taking place, no problem. But between system and surrounding, no heat transfer. Okay. Chalo. So now, what can I write this? Now it is mass of oil in, enthalpy of oil in, plus mass of water in, enthalpy of water in is equals to mass heat transfer. Okay, yeah, mass of oil exit, enthalpy of oil exit plus mass of water exit, enthalpy of water exit. Now it is steady flow, means mass inlet is equals to mass exit. So can I write here mass of oil inlet is equals to HOI minus HOE upon HO H water inlet minus H water exit. No, that will go on this side. So this is exit minus inlet is equals to mass of water. So this I need to find out. This I need to find out. So what do I need? I have already this. This is how much? It is 2.78. Now I need to find this. So I will find out that what is this? It is Cp यानी कि Cp of water, temperature of exit यानी कि 70 minus 25. 70 minus 25. The problem is I need to find enthalpy. And I can find that out. What is the issue? By enthalpy is equals to enthalpy of oil is equals to 1.68 T plus 10.5 into 10 to the power minus 4 T square. यही है ना? 10.5 into 10 to the power minus 4 T square. चलो. Temperature is 90 and 30. So oil inlet is equals to 90. कितना आ रहा है ये बताओ जल्दी फटाफट. कितना आएगा ये बताओ जल्दी फटाफट ऊपर वाला. ऐसी exit also we can find out at 30. How much is this? How much is this? This upper one you are going to get 159.7 kilojoule per kg and this 51.39 kilojoule per kg. Now we have both the things. I can write 159 minus 51 and I will get mass of water is 2.6. Now 1.6 kg per second. Getting it? Chalo, let's move on to the next question. A piston cylinder device initially contains, so I have a piston cylinder device, okay. Initially it contains M1 is equals to 0.6 kg. So M1 initially it is 0.6 kg of air with volume 1 is equals to 0.1 meter cube. The mass of piston is such that it maintains a constant pressure. Pressure remains constant. The cylinder is connected through a valve. It is connected through a valve. And a valve supply, what is coming? P inlet is equals to 5 megapascal and T initial is equals to 773 Kelvin. When air is allowed to flow steadily into the volume is double. V2 is equals to 0.2 meter cube and the temperature T2 reaches 250. So 250 is how much? 250 is how much? 523 Kelvin. At which point the valve is closed? Determine the mass of air entered and the amount of heat transfer. Mass of air entered. How much? So final mass, whatever is there. So how much mass has entered? Mass entered is equals to final mass minus initial mass. Now initial mass is known. How can I find out final mass? I know all these three things. M2 is equals to P2 V2 R T2. It is air, right? Air. So I know R. 800 into 0.2. It is 0.287 into T2 is 533. So M2 will be around 1.06. Let me check. How much is it? M2 is 1.066 kg and therefore it is 1.066. This given 0.6, so it is around 0.466. So this much mass has entered. This much mass has entered. How about heat transfer? How much heat is getting transferred? Heat entered, heat transfer. So I need to write unsteady flow energy equation. Unsteady flow energy equation means Mi Hi plus Q is equals to, अब nothing is going out, तो exit I will not write. I will write M2 U2 minus M1 U1 minus work of control volume. Let me write it on the next page. Let me write it on the next page. Mi Hi plus heat transfer Q in is equals to M2 U2 minus M1 U1 work of control volume. Now Mi, how much is coming in? How much is entered? How much is in? Entered is 0.466. 0.466 CPTI plus Q in. M2 CV T2 minus M1 CV T1 plus work of control volume is what? PdV. PdV. ये अनस्टेडी फ्लो है बाबा, अनस्टेडी फ्लो है, ये स्टेडी फ्लो नहीं है, अनस्टेडी फ्लो है ये. ठीक है, चलो. नाउ 0.466 1.005 इनलेट इज व्हाट? 773 ना, 773 plus Q in I need to find out. M2 is 1.066. CV I can take common outside. T2 is 533 minus M1 is 0.6. T1 is T1. T1 I don't know. I need to find out T1. So T1 is equals to P1 V1 MR. T1 is equals to P1 is 800, V1 is 0.1, mass is 0.6, R is 0.287. So how much is it? How much is it? $464.57 Kelvin. So I can write 464.57. Now CV I have taken out, so CV I can write 0.718 plus pressure. Pressure is 800 kilopascal and dV is 0.2 minus 0.1. Looks very big, but it's very simple. Okay. So now you can calculate everything you know. You can calculate Q in. Q in 564. What? Q in? Q in is not 564. It is minus 81.8 kilojoule. It basically shows it is heat out. Basically heat rejected. Heat rejected by the cylinder. It is minus 81.8 kilojoule. 564 क्या आया है? 464 आया है. टेम्परेचर ना. Yes. चलो नेक्स्ट क्वेश्चन. A Carnot heat pump working between 5 degrees Celsius and 60 degrees Celsius is driven by Carnot heat engine. So guys, always remember this designation, okay? If it is just heat engine or heat pump, always draw it like this. This is T1, this is Q1, this is T2, Q2. Now if it is engine, then ठीक है, work output, and it is driving anything, for example it is driving a heat pump, then always take it as Q3, T3, fix these designations, okay, fix these, Q4, and work input. The engine also runs a machine which is taking 30 kilowatt of power. The heat pump extract 17 kilojoule from, तो यानी कि this is 17 kilojoule per second from 5 degree. T3 is your 278 Kelvin. And this 60 means 333 Kelvin. This is 840. 840 is how much? 840 is how much? 840 plus 273 is 1113 Kelvin, and this is again 333 Kelvin. Okay, fine. Which of the following is correct? Heat supplied to engine, yani ki they are asking Q1, and total heat rejected to 60 degree means Q2 plus Q4. That I need to find out. So first of all, let's start with engine. So efficiency of heat engine is equals to 1 minus T2 by T1. So let me write directly. Now you guys are experts in this. 333 by 1113 is equals to work output by Q1. Now I am stuck. How much is this? I think around 0.6. कितना आएगा ये? 0.7. But I am stuck here. So I have no other choice but to move to COP. So COP is equals to, it is heat pump, means 333 by 333 minus 278 कितना आएगा? 60, यानी कि 55 आएगा. This is 55 is equals to Q4 by work input. Yes, work input. Okay. Now, can I write Q4? Q4 can I write as Q3 plus work input? Yes, of course I can write. And Q3 is how much? 17. Q3 is 17. So this is around 6.054 is equals to 17 by work input plus 1. Okay. So you can find out your work input is around 3.36 kilowatt. So you have found out this. Now what is work output, Baba? Work output is equals to 30 plus work input. है या नहीं? So it is 33.36 kilowatt. So we have found out work output. Now if work output is known, I can find out Q1 is equals to, work output is 33.36 by 0.7. So Q1 is how much? Q1 how much you are going to get? 47. So first we have done. Now I need to find out Q2 plus Q4. So what is Q2? Q2 is equals to Q1 minus work output. So Q1 is 47.66 minus work output is 33.66. It is around 14 point something, 14.3 kilowatt. Now Q4 can be written as Q3 plus W input. Q3 is 17 plus work input is 3.36, that means it is 20.36. So finally I will get Q2 plus Q4 is equals to 14.3 plus 20.36 यानी कि 34.66 किलोवाट. So this is your second answer. This is your second answer. आ रहा है इतना? आ रहा है या नहीं? बिल्कुल आएगा, क्यों नहीं आएगा? चलें आगे, चलें आगे. चलो क्वेश्चन नंबर 8. Engine with 20. Now we have fixed our designation. This designation is fixed. 1 2 3 4 I know. What is T1, what is Q1, what is T2, what is Q2. T1 T2 T3 T4 I know. Q1 Q2 Q3 Q4 I know. Okay, now I will not draw the diagram. Engine with 27% thermal efficiency is used to drive a heat pump with COP is equals to 4. The heat transfer from the heat engine and heat pump are used to circulate the water circulating through the radiator of a building. The ratio of heat transfer to the circulating pump water to the heat transfer to the heat engine, यानी कि नहीं आएगा, छोड़ देगा. क्या छोड़ देगा? इजी क्वेश्चन है तो यार, बिल्कुल इजी क्वेश्चन है, छोड़ना क्या है? ठीक है, चलो. सो दे आर आस्किंग हाउ मच हीट इज ट्रांसफर टू द वाटर. सो वाटर हाउ मच यू विल बी ट्रांसफरिंग बाई Q2 और Q4. इट इज द हीट रिजेक्टेड and divided by heat input to Q1. So you need to find out, sir, Q2 plus Q4 by Q1. This ratio I need to find out. This ratio I need to find out. Okay, chalo. Efficiency is given 0.27 is equals to work out by Q input. Okay, so work output is equals to 0.27 Q input. Q1. So what is Q2, baba? Q2 is Q1 minus W output. So it is 0.73 Q1. ठीक है, तो Q2 मिल गया मुझे. Q2 मिल गया पहले Q1 की फॉर्म में. Let's find out Q4. Q4 is what? Q4 is this. This is your Q4. This is your Q4. Now can I write COP is equals to Q4 by W input? Of course I can write. COP is 4. W input is equals to W output, means 0.27 Q1 is equals to Q4. So what is Q4? 1.08 Q1, right? It is 1.08, right? 4 into 0.27 is what? 1.08 Q1. So I found Q4 as well. So now can I write Q2 plus Q4 by Q1? Can I write Q2 as 0.73 Q1? Can I write Q4 as 1.08 Q1 by Q1? Q1 you can cancel out. You will get 1.81 is the ratio. 1.81 is the ratio of heat transfer to the circulating water to the heat transfer of the refrigerator. ठीक है, समझ में आता है? समझ में आता है या ऊपर से जाता है? चलो नेक्स्ट क्वेश्चन. This question I don't know, a lot of, I gave it homework in one of the previous sessions. This I gave as a homework in one of the previous sessions, and a lot of students keep asking this solution for this question. I don't know why. It is a very easy question. Okay, that's why I bring it this time. Two Carnot engine A and B are connected in series. One engine Q1, T1. Now Q2 is given to T2. This is W1, and the same Q2 is supplied to one other engine. Engine 2, it is engine 1. W2, and Q3 is given to T3. Between two thermal reservoirs maintained between 1000. Now this is 1000 Kelvin and this is 100 Kelvin. Engine A receives, this one receives 1680 kilojoule and rejects heat directly to engine B. Okay, ये directly reject हो रहा है, directly heat reject हो रहा है. Okay, if engine A and B are equal efficiencies, efficiency 1 is equals to efficiency 2, calculate heat rejected by engine B. यानी कि Q3 I need to find out. I need to find out Q3. Temperature at which heat is rejected by A, यानी कि T2 I need to find out, and work done by engine A and B. Very easy question. I don't know why each and every a lot of students keep asking. Someone specifically keep asking the solution for it. I don't know why. Chalo. You see, whenever efficiency 1 is equals to efficiency 2, T2 is the geometric mean of T1 and T3. So it is how much? 1000 into 100, and it is around 361. Let me check correctly. 316. 316.22 Kelvin. This is my T2. Now heat rejected by engine B I need to find out. So first of all I need to find out Q2, because I am giving Q2 here. Okay, chalo. So see, efficiency 1 is equals to 1 minus T2 by T1. So 1 minus 316.22 by 1000 is equals to W1 by 1680. So W1 you can find out from here. W1 can be find out from here. W1 is how much? 1148.7 kilojoule. Now if I know W1, can I find out Q2, which is Q1 by W1? So कितना आएगा Q2 by 1680 minus 1148, 532 kilojoule. Now I am giving 532 here. So I can find out W2 and Q3 as well. You see, efficiency 2 is equals to 1 minus 100 by 316.22 is equals to W2 by 532. So from here W2 will be known. W2 is how much? 363 kilojoule. So now this is 363 kilojoule, and Q3 is equals to Q2 minus W2, and it is how much? 532 minus 363 is equals to 169 kilojoule. Everything is known now to me. Everything is known. Heat rejected by B is known. Temperature is known. Work is also known. Everything. I don't know why one student particularly keep asking this solution. If you are not able to do these kind of questions, there is no trick in this. Nothing is there. So if you are not able to solve these kind of questions, that means your level is not as per requirement, as per the standards. Okay. Chalo. Similar next question. Now here work is same. Same question, but work is same. Okay. So this is for homework. Just remember, when W1 is equals to W2, T2 is the arithmetic mean, यानी कि T1 plus T3 by 2. So around 1, how much you will get? 550 Kelvin I think you will get, right? Yes. So very easy question. You do this, okay? So next question. A reversible heat engine draws. So I have a heat engine. It draws 5 megajoule from 400 Kelvin and does it 840 kilojoule of work. It also involves heat interaction from 300 Kelvin. Let us say this is Q2 and 200 Kelvin. Let us say this is Q3. Which of the following is correct? So what is going to 300, what is going to 200, I need to find out. Yani ki I need to find out Q3 and Q2 and Q3 and their signs as well. Ki are they going inside the engine or outside the engine? Okay. Chalo. So first I can do is energy balance. Energy in is equals to energy out. Now what is going in? By 5000, let us say kilojoule plus Q2 is going in plus Q3 is going in, 840 is going out. So can I say Q2 plus Q3 is equals to कितना आएगा ये 5000, 840 minus 5000 minus 4160 आएगा. But one equation, two unknown. So I need one more equation. What is that equation? Cyclic integral of dq by t for a reversible cycle is equals to 0. So can I say 5000 by 400 plus q2 by 300 plus q3 by 200 is equals to 0. ठीक है. So if I take what 1200 326 15, what can I take? 1500. $15,000 I can take common. 15,000, okay. So 15,000, 4,000. 4, 3, 2, 4, 2, 2, 3, 1, 2, 3, 4, 400, 1200 I can take. Sorry. Sometimes very small things just mess up in your mind. 1200. So 3, yani ki 15,000 plus 4, 3 4 is 4 Q2 plus 6 Q3 is equals to 0. Yes. Sometimes very small things just messes up your mind. Chalo. Very good. So I can get what? 4 Q2 plus 6 Q3 is equals to minus 15,000. So now I have one equation, two equation. You can find out Q2 and Q3 with sign as well. So what will you get? How much? Okay, so Q2 you are going to get minus 49. Let me check first of all. Q2 is what I have taken. Yes, correct, I have taken kilojoule, and Q3 is 820 kilojoule. Now what does it mean? It means that Q2 is in the opposite direction of what you have assumed. So you have assumed like this, but if it is negative means it is rejected. It is rejected. So B is correct. And 820 is positive means your signs are correct. Means 820 kilojoule is given to the engine. 820 kilojoule is given to the engine. ठीक है. चलो. A resistor of 30 ohms is maintained. I have a resistor. 30 ohm resistor is maintained at constant temperature. Temperature is surrounding temperature, okay. Is 27 means 300 Kelvin. While a current 10 ampere is allowed to flow for 1 second. Time is equals to 1 second. Calculate the entropy change for resistor. Now see, this is your resistor basically. And let us say temperature remains constant. Okay. So entropy change for resistor is equals to Q by T. Now tell me, how much heat is getting transferred? How much heat is getting transferred to the resistor? How much heat is getting transferred to the resistor? There is no heat transfer to the resistor. No heat is transferred to resistor. You are not transferring any heat to resistor. Okay. What is going in? What is going in is electrical work. Okay. Electrical work you are giving, no heat is given, is equals to I square RT. That means 10 square, 100 square, no, 10 ampere. 10 square, R is 30, time is 1. So this is 3000 joule. 3000 joule. Yes. 3000 joule. Yes. So you are giving electrical work. Electrical work. You are not giving any heat. So entropy change for resistor is this, 0. What about surrounding? What about surrounding, Baba? What about surrounding? Some whatever heat you have given, whatever heat you have given, or whatever work you have given in the resistor, it will be converted to heat. In the resistor, it will be converted to heat. But you are giving this electrical work, but resistor will convert it into heat. This heat will go to surrounding and it will change the entropy of surrounding. So it is plus Q by T of surrounding. Now how much heat is going? 3000 by 300. So it is 10 joule per Kelvin. Therefore entropy change of universe is equals to 10 joule per Kelvin. 10 joule per Kelvin. C is correct. Yes. Chalo, next. A aluminium block. I have an aluminium block. Cp mass is 5 kg. Cp is 400 joule per kg Kelvin. Is initially at 40 degrees Celsius in a room, air at 20 degrees Celsius. So initially it is at 40 degree, means temperature is equals to 40 means 313 Kelvin. And the surrounding room is at 20 degree, means temperature is equals to 293 Kelvin. Now it is cooled reversibly by transferring heat to a completely reversible heat engine. So you are cooling this. You are cooling this by transferring heat through a heat engine until the block reaches, यानी कि T final is equals to again 20 degree, यानी कि 293 Kelvin. The 20 degree room serves as a constant temperature sink. This temperature is constant. Compute change in entropy for the block. So if I am supplying Q1, reject Q2, work will also be produced, work output. Entropy change for the block. Now see, for the block, always guys, always go with the basics. Always go with the basics. Is it isothermal heat transfer or non-isothermal? It is non-isothermal heat transfer. If it is non-isothermal, is it solid, liquid or gas? It is solid. So use the formula mCp ln T final by T initial. Mass is 5, Cp is 400, ln 293 by 313. This is your entropy change for your block. For your block. So कितना आएगा ये? कितना आएगा? Minus 132.06 joule per Kelvin. Joule per Kelvin. Okay. Entropy change for the room air. Room air. Now room air. By how much heat you are giving? Q2. Q2 heat is given. So can I write Q2 by Q by temperature of room? And how much heat is coming? Q2. So can I write it as Q1 minus W by temperature of room? Temperature of room? Yes, of course I can. Now what is Q1? Q1 is heat coming from the block. So it is mCp dt minus W by T room. Now problem is I do not know work. The problem is I do not know work. So I need to find out work. And what do I know? I know entropy change of universe is equals to entropy change of system plus entropy change of surrounding is equals to 0. Greater than equal to 0. It is a reversible process, so it will be equal to 0. Now entropy change of system is given as 132.06, and for surrounding it is this Q1. Q1 is how much? Q1, calculate Q1. Mass is 5, this is 40, delta T is 20 degree. So how much? 40,000, right? 40,000 ना, कितना आएगा? 40,000, ठीक है. So this is 40,000 by 293 minus W by 293 is equals to 0. From here you can get your work output. Whatever work you are getting, you will put it here. You can find out this work, you can substitute here. 293, you can find out entropy change of air as well. कितना आएगा work? 1306 joule. So you can find out 1306 here, and entropy change of air is how much? कितना मिलेगा? It is, for room it is 132.06. 132.06. ठीक है, चलो, very well. Next question. Now this is available energy for closed system. I have a mass of 2 kg of air in a vessel expands from, mass is 2 kg, expands from 3 bar, यानी कि P1 is equals to 3 bar, T1 is equals to 70 means 343 Kelvin, to P2 is equals to 1 bar, and T2 is equals to 40 means 313 Kelvin, while receiving 1.2 kilojoule of heat from a reservoir at 120, यानी कि T reservoir is 120 degrees Celsius. Q is coming in is 1.2 kilojoule. Ambient pressure is this, T surrounding, T naught is equals to 300 Kelvin. Available energy. I need to find out available energy. भैया SFD VMD नहीं, मैं थर्मोडायनेमिक साइकिल बना सकता हूं. ठीक है, जो तुम्हें पूछना वो पूछ सकते हो. SFD VMD वो बता पाएंगे हमारे धीरज सर या हमारे अभिनव सर, है ना. मेरा सब्जेक्ट तो नहीं है, मैं तो TSPV डायग्राम बना सकता हूं. ठीक है, चलो. अवेलेबल एनर्जी. नाउ अवेलेबल एनर्जी फॉर क्लोज सिस्टम इज व्हाट? योर phi1 minus phi2. phi1 है ना बाबा. अभिनव सर पढ़ा तो रहे हैं, अभिनव सर धीरज सर पढ़ा रहे हैं. ठीक है, चलो. नाउ व्हाट इज phi1? इट इज u1 minus t naught s1 plus p naught v1 minus u2 minus t naught s2 plus p naught v2. ठीक है, so I can write u1 minus u2 minus t naught s1 minus s2 प्लस पी नॉट V1 माइनस V2. ठीक है. Now you know everything. You know T1, you know T2. So you can write M Cp. It is air. So you know Cv as well. So you can write T1 minus T2 minus T naught. T naught is 300. S1 minus S2 is what? S1 minus S2 is Cp MCp ln T2 by T1 minus MR ln, it is T1 by T2, सॉरी, यहां पे 1 माइनस 2 है ना, सो T1 by T2 P1 by P2 प्लस दिस इज योर 0.8 into 10 to the power 2 and V1 minus V2. You can find out V1 from here, V2 from here. V1 is equals to P1, sorry, M RT1 by P1. V2 is equals to M RT2 by P2. ठीक है. So now you know everything. You know everything. You know mass. You know CV of air 0.718. T1 also you know. T2 also you know. Mass you know. CP you know. T1 and T2 you know. MR you know 0.287. P1 P2 you know. P1 P2. And this V1 V2 you can find out. And finally your available energy will be how much? It is 65.748 kilojoule. This will be your answer. ठीक है. चलो. Similarly, last question is there for you. I was thinking of doing it, but you can do it for homework. Now, this will be the last question. Open system available energy. Open system. Simply, what you need to do? It is a compressor. If it is a work, compressor means available energy. Minimum I need to find out. Minimum means phi 2 minus phi 1, and it is H2 minus T naught S2 minus H1 minus T naught S1. So you can write out H2 minus H1 minus T naught S2 minus S1. Now everything you know. Same question like last one. Okay, so this you can finish it in homework. 2 questions I have given you for homework. ठीक है. चलो. Let's stop here, guys. Let's stop here. I think we have done enough for today. Tomorrow we have crash course practice questions. Guys, I have brought to you very selected questions. Okay, I have a big collection of questions, but I have brought to you very selected number of questions, which is important. Basically, these type of questions you can see. Okay, and these are not just gate questions. They are not previous year gate questions. They are practice questions that I have taken from book. Okay, so these questions, if you practice, it will be very, very helpful for you. Okay, tomorrow also we will solve some questions on applied thermodynamics. So do practice these questions. And guys, Abhinav sir is coming up with our workshop for GATE 2025 on 6th of December at 7:30 p.m. So do join, and also on 10th of December, if you are planning if you are planning for Vision GATE 2025 or any batches, you can go for a scholarship test. Okay, on 10th of December you can get to 90% of scholarship. क्या कह रहे हो यार? क्वेश्चंस जूम कल का क्लास में लेकर आइएगा. अच्छा, जूम करके छोटे हैं क्या क्वेश्चन? ठीक है, आई विल जूम इट. मोबाइल में देखते हो क्या? आई विल जूम इट. ठीक है, नो प्रॉब्लम. ठीक है, सो you can get all the information, and on the app as well. You can download the app by clicking on this link or by scanning this QR code. Directly you can click on this link, directly it will take you to the app. Okay, chalo, very well, very well. Also, if you have not joined my Telegram group, do join the Telegram group, because I will be sharing this PPT on the Telegram group itself. Or if you have any doubt, you can connect with me anytime through this Telegram group. ठीक है, चलो स्टॉप करते हैं यहाँ पे गाइज, स्टॉप करते हैं, मिलते हैं वेरी सून, कल मिलते हैं, ठीक है, चलो, वेरी गुड. Thank you so much guys, bye bye.